Apple is red. Banana is yellow. Leaves are green. No, no, no. Apple is not red. Banana is not yellow. And leaves are not green. It is believed the color of the object is what it reflects. Red objects reflect red, yellow reflects yellow, and green reflects green. But this is not a complete story. As we know, every color comes from our sun. Our sun is the founder of millions of colors we enjoy seeing. But what color is our sun? You may say yellow or red. If you went on the trip to the International Space Station and looked at the sun, you'll find our sun white. Pure white. And nothing can be pure white except unfiltered sunlight. And nothing can be pure black except depth of a black hole. But our sun is not even white, because white is not a color. It doesn't have its wavelength like other colors do. To know the real color of our sun, we have to look at the rainbow. People might think rainbows are lame, but it's the only rainbow that shows us the real color of our sun. But if sun is a mixture of 7 different colors, then white appears white to us. As we know, light travels in the form of wavelengths, and the frequency of wavelengths decides which color it will represent. All the light sun emits, only a small proportion of light we can see. We call it visible light. And visible light contains all 7 colors of the rainbow. Among the visible wavelengths, violet has the shortest wavelength, red has the longest, and all other colors lie in between. To see the visible wavelengths, humans have evolved with 3 types of cone cells: L cones, M cones, and S cones. Where L cones respond the most light of longer wavelengths, M responds mostly medium, and S responds most to shorter wavelengths. Like when you see a yellow object, yellow wavelength falls in between L cones and M cones. So both L and M cones are simulated simultaneously to make us see yellow. And to see red color, L cones are simulated significantly more than M cones. But when 3 cones gets activated at the same time, our brain perceives it as white color. Let's go back to the sun's color. When we see sun containing all the visible colors, all our 3 cones get hyperactivated and signals that significant colors are received at all visible wavelengths, and our mind perceives that as white. But sun looks white and ice looks white for 2 different reasons. Sun contains all the visible colors that we can see. On the other hand, ice just reflects back the visible colors they receive from the sun. They have no colors on their own. Let's come back to our apple. Apple is not red because when sunlight containing all the visible colors falls into an apple, all other colors get absorbed, but only red is reflected. The real color of the apple is orange, yellow, green, blue, indigo, and violet. That is what it has absorbed. You see apple red because that's not what it is, but that's what it sent back to you. There is no red around in the skin of an apple. So apple is every color except red. And it's true for bananas and leaves. Leaves are green not because it contains green molecules on it. No, no, no. Leaves are green because it absorbs all other wavelengths of light except green. All the green light is reflected back. An object isn't really its color. But how come objects are deciding their own color? How apple decides not to be red and leaves not to be green? Apple rejects red color because when lights fall into apple, electrons in the atoms of apple only absorb light of wavelengths representing the amount of energy needed to jump from ground state to higher energy state. All other energy of light will be reflected back. And every object has its own characteristic pattern of energy they allow and reject. And if any objects reflect every color of this spectrum, then they look white. White objects don't absorb any light. They have no color on their own. On the other hand, black does just the opposite to white. It absorbs all the colors of the spectrum and reflects no light. If you take an apple in the light source which doesn't consist red on it, what color apple will be? It will not look red because light source doesn't consist of any red on it. The apple will look black. Apple's skin will absorb all other wavelengths of light and no light will be reflected. And if object doesn't reflect any light, it looks black. Everything that physically exists in the universe reflects light except a black object. So black and white are called opposite colors. One only absorbs and the another only reflects. But how can we see millions of colors if the visible spectrum contains only 7 colors? Here the magic begins. Some objects reflect one wavelength of light, like in the case of apple and leaves. But some other objects reflect more than one wavelength of light. If you see purple objects, purple is not the color of light and doesn't have its own wavelength. You can see purple objects because it sends 3 wavelengths of light: red, blue, and violet, in various proportion. And when these 3 wavelengths strike on your eyes, you perceive it as purple. Other colors outside of the visible spectrum are mixtures of two or more wavelengths of light. So objects have their own secrets. Like it is being said, never judge a person by their looks. Never judge an object by its color. Thanks for watching. Subscribe to Crazy Science by clicking here.